Hey, what's going on, guys? Z here. In this video, finally we're gonna create a 3D projection. So all the effort we did put into this project from now on would start getting rewarded. But before we start, let me show you how the game we're developing is gonna look like at the very end, just to keep your motivation. Okay, so current output we have looks like this, and now we need to clean up the code a little bit in order to proceed. So the very first thing to consider, I want to scale map to make it smaller, and I want to put this into the top left corner. So let's get started with that. Sort of a thing, and then we're going to be using the map offset X and map offset Y, the newly updated ones, to properly place our 3D projection into this 300 by 300 by 200 pixels area, which serves like the game area, the place where the entire game action is going to be happening. Okay, so I scroll down here. Well, let's start with getting rid of what we don't need any longer. So we don't need this sort of a thing. Okay, so we don't want to draw the rays anymore. Okay, yeah, so here we're gonna want to render 3D projection, but this comes a little bit later, so I don't want this stuff. I don't need this as well. Okay, all right, okay. And also I want to draw the map after we will draw the 3D projection in order to overlay the map onto the 3D projection. However, the offset stuff would still remain right over in here. So I just want to grab the part to draw the map. Okay, and cut it from here and paste down below here. Okay. So let's have a look. Okay, so didn't break anything, which is good news. Okay, so now let's scale map a little bit differently. So instead of multiplying by the map scale, let's multiply by a small constant of 5. That's pretty reasonable size for a map I came up with using trial and error method, and respectively we'll have the width and height for every single given tile equal to 5 pixels, but it would be scaled because we just resizing our game game area just to fit as if this was a real 300 by 200 pixels like full screen mode. Okay, so now this should be okay, player X. Yeah, and now we don't have the player. Player is not gonna match. So player. Nope. Well, okay, let's have a look. Let's have a look what we got. Yeah, you say like player. Does it, or is it? Hold on a sec. No, yeah, it just doesn't match. So where is the player? Player map X, player map Y. Yeah, so I need to adjust the player map X and the player map Y. Okay. Yeah, here it is. So we need to scale the player position as well. So I say player X divided by the map scale and multiplied by this constant of 5, and the same for player Y. So here we go, and Now let's have a look. Sorry, just rename the file. As always, I forgot to update the file name for next part. Okay, and now, yeah, now I see like the collision detection has been restored because we have the proper scaling. And now the very last thing, we need to put this right over in here. So in order to do that, let's do the following thing. So we need to do like this, minus 149. Well, actually 150, but there would be some, this is not going to be very pixel perfect, so this should be like this. Okay, and this one, I've already figured out that this should be equal to 4, because this here we have the 4 pixels, if just bear in mind the transformation. Okay, and if I did everything properly, I should now draw the map here. Okay, good, so this is kind of it. And another thing, I don't want this map to be shown all of the time, so I just want the map being shown only if I press some key. Well, I was using tab, but tab actually navigates through the browser, so we're going to be using shift instead. So here, let's just say console log and event key code. And yeah, by the way, we can also add some commentaries which button is which, so it's also going to be a good idea. Okay, so, and it's, you see, like it scrolls to the left, which is good as well. So now, so shift is, did I update? Yeah, shift is 16. So here, case 16. So we'll say show map equals to true, and break in here, copy and paste, show map would be equal to false. And don't forget to provide this show map. So variable show map is equal to false by default. Okay, and now, yeah, just to give a bit of an idea what the buttons are all about. So here this is the left shift, show map. Okay, show map, and then so 38 is forwards, so let's put it actually first. So here we have arrow up, so here respectively we have the arrow down. Okay, left 37, arrow left, and here, so 39, right? Yeah, arrow right. Okay, so okay, left shift to show the map. This is it. And well, this is self-explanatory as well. We can only just probably make it like so, just to keep the order properly. Yeah, and hope I didn't break anything. So let's have a look. Yeah, and one more thing. So we want to draw the two-dimensional map only. Well, it's actually draw map on left shift press. So if show map, in this case I want to draw the map. Okay, so I'm pressing shift, and now, yeah, you see like everything is still working. Great. And yeah, by the way, as I've been mentioning earlier, the player speed is now also relative to the map size, so it's also a good idea. Okay, so this is pretty it, and now we can directly go to our 3D projection. Alright, so yeah, right over in here, so the very first thing to consider, we need to create a variable called depth. And remember, we've been considering the ray and x and ray and y coordinates in the previous part, from those intersection that results in a shorter line. But for rendering the 3D projection, all we'll need is depth. So literally we need either the vertical depth or the horizontal depth. So depth is going to be equal to, and now the ternary operator, so vertical depth is less than horizontal depth. And if this is true, then depth is going to be equal to vertical depth. So vertical depth. Otherwise, it would be equal to horizontal depth, like this. So yeah. And the next thing to consider, we need to calculate the wall height. So variable wall height dependent on the depth. So I mean, like those walls that are kind of stands further from the player, they would be kind of less small to like shorter, and those that are closer to the player, they would be taller, like this. And I've already came up with a formula that actually loads this, and also we need to make sure that the map height is not gonna overlap the 200 pixels. So we don't want the wall to be kind of too high. So we can simply say math.min, and considering the minimal value for wall, so either this would be a map scale. So I came up with this formula kind of like using trial and error method. It just gives a wall height that I like how it looks, divided by depth plus 0.001. So this is needed to avoid division by zero error. Okay, so this is the first case, and the second case is the height itself. So otherwise, if the wall is too high, we just limit the wall height with the height of our screen. That's pretty it. And now we want to pick up the color, how to paint our walls. So I can say context dot fill style. Well, let's start with something fixed. So let's say like a like this. And now we need to draw a rectangle. So for every ray we're casting into our world, when it hits the wall, this should be kind of the rectangle should be rendered on the screen. So this is the heart of the entire projection rendering. So just hope it's clear. So I can simply say context dot fill rectangle, and we'll come to the offsets a little bit later. So first I just want to show you this thing as is, and then we're going to be adding the offsets to make it clear as well. So from the leftmost of the screen and ray by ray, or like line by line, vertical line by line, from the left to right, we want to have an offset. And as far as we have the number of rays being equal to number of pixels within our height, then the offset would always be 1. And in this case, we can use our ray counter. So like this would be like x, y, and then width and height. So for x, we're going to be using our ray. Now for y, we're going to be using well, just wait, no, don't need offset for now. So here we say height divided by 2 minus wall height divided by 2. And probably we don't even need the parentheses here. Well, at least for now. And the width and height. So the width of every rectangle would be equal to 1 pixel, because again, like we have 300 rectangles, we have 300 rays being casted into the world, and the width of every of them is going to be only 1 pixel in this particular certain case. And the height of this rectangle would be equal to the wall height. So that's pretty it. And without further ado, I hold my breath let's have a look what we got. Probably we got an error. Okay, depth, it's just a typo. Depth, where is this? Okay, so let's have a look. Yeah, and here finally we have our projection. However, the problem is that you see, like, we have our projection in the top left part of our screen, but we want this to fit our game area. So in order to fix this, we can simply say map offset x plus, and here map offset y plus, and let's just, for safety reasons, let's take this into the parentheses, save, and now it should be rendering exactly where we want this. But here is the problem, guys. You see, like, what you currently experience when you see on your screens is known as the fisheye effect, and the reason for this is quite pretty clear, because the ray that comes like from player to the wall here is longer compared to the one coming from here to here. But we don't really want this, and we want the wall be having exactly the same height. And there is a magic math formula that I have no idea how it works. However, I'll just show you how to use it. So we say depth multiplied equal by math.cosine, and now player angle minus current angle. This is gonna fix this fisheye effect. Don't ask me why this works. I have no idea, because I'm complete dumb in math. But you see, like, now we have normal walls. We no longer have this fisheye effect. But you see, like, the problem is that we can distinguish the edges. So all edges that go in like this, and then all edges that go in like, oh my god, how to show this? Yeah, so edges that go in like this and edges that go in like this. So like x edges and y edges, let's say. So we have a look at here. So, or even let's better have a look at the map. So let's say this edge should be one color, and this one, and this one should be another color. So we can, and by the way, when it comes to texturing, this is going to be the topic of the next tutorial. We also want to be I'm sorry, guys. We're also going to be distinguishing between the kind of X and Y textures, because when it comes to the walls, we want like stones here and like door. It's not really door, but the place where the door is coming to. So we want one texture here, another texture here. So that's essential. But now we just use the placeholders, like just a proof of concept. So here we use exactly the same principle. So we would be distinguishing by the depth. So we can distinguish between this color and, say, I don't know, 555. Let's take like something like this. And if we update, so here we have just differing colors. And again, like later on, these differing colors are gonna be replaced by on-demand textures. Not obviously that would be different textures, but in some case that might be on the card. So I hope it's clear. And yeah, quite a strange thing that even though my video recording software is running, that FPS is not actually dropping that much as it was when I've been doing the same using Python and Pygame, and I have no idea how on earth is that possible, because Python and Pygame should be faster than JavaScript, but well, that's beyond my understanding, to be honest. Okay, guys, so the very last thing we're gonna consider, and that's probably something most of you are gonna be interested in, is how to resize the game world, the game map, how to make it bigger. Okay, so if we just go right over in here, and let's consider not 16 by 16 by 32 by 32 map. And now I just can grab the map and double its size. So here, let's say I can take like copy and paste. So I'm just making the map like 32 by 32 elements. That's pretty simple. Okay, and here, great. And just to give player an option of walking through the walls, so let's make a couple of holes in the walls like this. So let's make a hole here as well. Okay, maybe a hole here, and yeah, maybe just make some, I don't know, whatever shape like this. Okay, and let's get rid of this one. Don't need this really. And here, well, let's say do something like this. Just building the random walls. I hope I don't place the player in the center of the wall. By the way, yeah, I'm sorry, just shift here. Okay, so this is how it looks. Okay. So I'm just trying to figure out where is the starting point. Oh, yeah, here is. Yeah. Okay. So let's say, yeah. And now we can explore another room right over in here. Okay. And also we can explore this one. You see, like the map is now much bigger. Okay. So yeah, we see like where exactly on the map we currently are. Yeah, we can step in. Great. Okay, yeah. And let's inspect the very last room. Okay, let's inspect this one. Yeah, it's gonna be quite pretty empty. Nothing much here, but anyway, so this is how we can build like the levels for our game by simply adjusting the one-dimensional array in the source code. That's pretty it. And when it comes to texturing, we're gonna be just using different. We're gonna be using other digits but one, like say 1 for stone walls, like 2 for bricks, 3 for something else, some specific numbers for like place your advertisement here, like some pictures on the wall. So yeah, but anyway, that's gonna be the topic of the next tutorial. And for now, I think this is pretty it. And yeah, so this is it. Okay guys, so thanks for watching. Hope to see you in the next tutorial in this series on how to code a Wolfenstein 3D using pure JavaScript. So until that time, and take care.